Today we're going to talk about a particular force, the force of gravity or weight. In equation form, the force can be written in the form of F sub g is equal to m times g, where m is the mass of the object and g is the gravitational field. Now near the surface, g is equal to 9.8 newtons per kilogram. It's that same 9.8 meters per second squared that we learned about in the section on acceleration. Now, if you're standing on a scale, you want to measure your weight. What happens if you draw a free body diagram, you'll see that you are the object, you are the dot at the center of the diagram. Weight is the force of gravity. That is equal to m times g. That force is directed downward. The scale is going to push back on you with an equal and opposite force. So if you're standing on a scale and sitting still, or if you were moving at constant velocity for some reason, the force of the scale upward on you would be equal to the force of gravity. Now let's consider an unusual situation. Suppose you got onto a scale on an elevator where the elevator could be accelerating upward or downward. What would happen to your apparent weight in that case? Well, if you were standing still, the net force would be zero, there'd be no acceleration. If you were moving at constant velocity, acceleration would be zero, net force would be zero. In those cases, the force of the scale upward would be equal to the force of gravity. If we look at the situation here in figure 12, here we have someone standing on a scale in an elevator that is accelerating upward. In that case, given that we have acceleration upward, we have to have a net force upward. That means that if you take the sum of the two vectors, the force of the scale that's upward and the force of gravity downward, we will have a net force up, which further means that the force of the scale is greater than the force of gravity. You could find the force of the scale by taking the magnitude of the force of gravity and adding the net force to it in that situation. Similarly, if the elevator were accelerating downward, then the net force would be downward. That means that the force of the scale would be less than the force of gravity. When you do these types of problems, you'll see that the force of gravity is always equal to m times g. We're only going to work with situations on the Earth's surface where g is equal to 9.8. So in these cases, the force of gravity is always going to be just the mass times that 9.8 meters per second squared. The force of the scale will depend on whether there's a net force, whether there is some acceleration. So these are the types of problems that you have to work on for the launch homework. So look at these, be able to calculate the force of gravity. Remember, force of gravity is measured in newtons. Weight is always in newtons, while mass is in kilograms. So have at it.